Okay, so I'm going to teach you how to derive parametric equations. First, let's start off with the example of, let's see, x equals t to the third, and y equals e to the 2t. Okay? That's a 3. So, first thing you know about deriving parametric equations is that they follow along the pattern of dy over dx equals dy over dt over dx over dt. This is because if you flip and multiply, you get dy times dt over dx times dt, and then everything, the dt's cancel out, and so you end up with dy over dx. So with our example, dx over dt would equal 3t squared, just because to the third, derive it, yeah. And dy over dt equals 2e to the 2t, because again, e to the 2t derived is that. And following by the pattern of dy over dt all over dx over dt, you end up with 2e to the 2t over 3t squared. And that is the first derivative of the parametric equation. But then you might want to do a second derivative, which is a little bit different. Basically, you use the derivative of a quotient rule, the chain rule. So you derive 2t, or not 2t, 2e to the 2t. So you get 4e to the 2t. But since it's a derivative and since it's in parametric, you need to multiply by dt over dx. Times 3t squared minus, this is gonna get messy, 2e to the 2t times 6t, and then it's a derivative, so multiplied by dt over dx, all over 3t squared squared. Hopefully you can kind of read that. Hopefully you know why we do that. If you forgot what the quotient rule is for deriving, it's just u prime times v minus v prime times u over v squared, where u is the number in the denominator, in the numerator, and v is the number in the denominator. So, yeah. Okay. But now we need to figure out a way to get rid of the dt over dx, and since it's in the numerator, it can be factored out. Since dt over dx is the reciprocal of dx over dt, you can divide by dx over dt, which is basically 3t squared. So if you divide, so basically divide, let's see, okay, divide this right here, 12t squared e to the 2t minus 12t e to the 2t, and that's all over 3t squared squared. So divide all of this is, divide all of that by 3t squared. The 12t squared e to the 2t minus 12t e to the 2t all over that's basically the simplified version of the quotient rule that we just did without the dt over dx. So yeah, if you divide all of that by 3t squared, you end up with 12t squared e to the 2t minus 12t e to the 2t all over 3t squared to the third. It's to the third because when you divide by 3t squared, you just get another 3t squared in the denominator, so you change that exponent of 2 to 3. And this simplifies to 12t e to the 2t, t minus 1, all over 27t to the 6th. And that would be your answer. The formula that was created basically for all second derivatives of a parametric function is d squared y over dx squared equals u prime v double prime minus u double prime v prime over u prime 3, where u equals x and v equals y. If you just follow that format, that should basically get it for you without all this other stuff of converting dt over dx and reciprocals and whatnot. So that's basically it. Ta-da! Alright.